Hi everyone, this is a boating problem with two parts. A boat is being pulled into a dock by means of a winch 12 feet above the deck of the boat. Okay, the winch pulls in rope at a rate of 4 feet per second. Determine the speed of the boat when there's 13 feet of rope out. What happens to the speed of the boat as it gets closer to the dock? So that's part A. And then again, we're going to do it again. What happens to the speed at which the winch pulls in the rope as the boat gets closer? So this one looks like it's the same problem. Maybe I did something different. I think I copied this down, the same thing. Let's see. 4:13. I think these are the same thing. So anyway, I drew a picture of this, and so this is the rope extended at 13 feet, and the length of this is 12 feet. So basically, let's let L be the length of the rope, and so it's going to be length squared equals y squared plus x squared. So that's 12 squared plus x squared. And we're going to get, take the derivative of this, and you're going to get 2L times the derivative of the length with respect to time equals, this goes away, so you just have 2x times the derivative of x with respect to t. So, our derivative of x with respect to t equals this. So this is going to be ln L over x times derivative of L with respect to t, because the 2's will cancel. Basically, I'm just dividing both sides by x here. Alright, so we need both. We have this one and the other one. Now, when you clean this up, we're going to get this equals -4 over L over x, because dl over dt equals -4 feet per second, because that's what they're bringing in the boat. That's the speed of the bringing in the rope, like pulling on it. Okay? Now we have to discover when L is 13. We get, when L is 13, you should just know that x is 5. Because basically this is a right triangle, and these are your Pythagorean triples. But anyway, you would get x equals L squared, which is 13 squared minus 144, and square root of that is just going to be 2. It's going to be square root of 25, which is 5. So when you see your Pythagorean triples, you can make life easier. So basically, the derivative of x with respect to t equals -4 times my L, which is 13, over 5. And that equals -52 over 5, which is -10.4 feet per second. That's how fast it's changing as the speed of the boat increases. Okay? So now it's asking if d of x of dt equals -4 and L equals 13. So basically what we're doing is we're taking dl, we're just using the other formula, which is x over L times dx dt. And this is going to be 5 over 13 times -4, which equals -20 over 13 feet per second. So, now if we do the derivative of L with respect to t, we're going to take the square root of the length minus 144 over the length times negative 4. And if I take the limit as L approaches 12 from the right side, this is going to be the limit as L approaches 12 from the right side of negative 4 over L. I'm just putting these two together, times the square root of L squared minus 144. And when I plug in 12 in here, I'm going to get this equals 0, so we're going to get negative 4 over L times 0, and that's going to equal 0. Okay, that's all. Thank you. Have a nice day. Bye-bye.